Hello students, in our last class we have discussed about coordinate systems, perpendicular coordinate systems, or we can say orthogonal coordinate systems such as Cartesian or rectangular coordinate system, cylindrical coordinate system and spherical coordinate systems, and how to get the differential length, differential surface area and differential volume with respect to three different coordinate systems. So these are the topics we have seen. So in this particular class, let us move on to vector basics, that is vector algebra. So algebra in the sense how to perform the mathematical operations with respect to vectors such as addition, subtraction, multiplication and division. So these mathematical or arithmetical operations are performed on vectors. Okay. So we are not giving much interest towards the scalars, because scalars are the constants which has only magnitudes, but vectors has both magnitude and direction. In electromagnetic wave theory, vectors are very important. So our concentration is towards the vector algebra. Okay, in this class let us discuss about vector algebra. Vector algebra. In vector algebra, we need to have three different operations. One is addition. First one is vector addition. Okay. Second operation is vector subtraction. Third one is vector division, and one more operation is vector multiplication. Vector multiplication you will see in the next session. Okay. Vector addition. Let us go with vector addition. Let us consider two vectors. Let us consider two coplanar vectors. Coplanar means two vectors are in same plane. Coplanar vectors A and B. Let us consider two coplanar vectors A and B. So let us have two vectors A and B in this fashion. So in order to perform addition between these two vectors, the resultant vector is C. Vector C is equal to vector A plus vector B. How to perform vector addition between two coplanar vectors? This can be performed by using two methods. One is parallelogram method. Parallelogram method. Second one is tail to tip method. These are the two methods we are going to use in order to perform vector addition. So let us go with first one, how the parallelogram method can be performed. Let us consider this as vector A and this as vector B. So we know that in parallelogram opposite sides are parallel to each other. Then this becomes vector B again, and this becomes vector A. This is vector A and this is vector B. Then its resultant is the diagonal of this parallelogram, that is C. Diagonal of this parallelogram is the resultant of these two vectors A and B. Now the resultant is addition of these two vectors. Therefore C is equal to A plus B. This is how the first method of vector addition can be performed. In the second method, tip and tail method, see, consider this as vector A and this as vector B. Okay, then the resultant vector is drawn from tail of this vector A to tip of the vector B. Hence the name tail to tip method. See, in order to obtain resultant of two vectors in this method, we are drawing this line from tail of first vector to tip of second vector. The vector C is the addition of vector A and B. These are the two methods which we are going to follow in order to perform vector addition. Okay. Coming to the vector subtraction, how this can be done? See, suppose C is equal to A minus B. This is the expression given. Okay. C is the resultant vector, A and B are the two coplanar vectors. What is this negative sign indicates? Negative sign indicates the opposite direction, not with respect to the magnitude. The magnitude of B is positive, but the direction of B is in the opposite way. Okay. Let us consider this form. Okay. Name this as vector A for time being and this as vector B. Okay. So here A is positive and B is positive. Since we are performing subtraction operation here, minus B represents the opposite direction. Minus B represents the opposite direction with same magnitude. This is minus B. Okay, this expression can be rewritten as C is equal to A plus of minus B, like this. What is this minus B? Minus B represents the same magnitude with opposite direction. Then the resultant, by using the parallelogram method, the resultant is in this fashion. C is equal to A minus B. Got it? This is how we can perform the subtraction operation. In subtraction operation, negative sign shows its direction. Keep that in our mind. Okay. Then coming to the vector division, how division operation can be performed on vectors? We cannot divide two vectors like this. So this operation does not holds good here. So we can divide a vector A by a scalar component, or we can multiply the inverse of the scalar to a vector. These two operation holds good. This is how we can say vector division operation. This division of two vectors is not possible. Okay. So only scalar division or scalar multiplication can be performed with respect to vectors. Got it? Then move on to the next operation, vector multiplication. Vector multiplication. This vector multiplication can be performed with respect to two operations. One is dot product, second one is cross product. Dot product is also called as scalar product. Second one is vector product. Okay. So we can perform vector multiplication in two ways. One is dot product and another one is cross product. Got it? Now let us move on to the dot product between two vectors. So let us consider a vector A and vector B. We have two vectors A and B. Okay. Now we need to perform dot product between these two vectors. In order to do so, let us consider two vectors, vector A and B. So the angle between these two vectors is very important, that is theta AB. The angle between vector A to B is represented as theta A into theta AB. So in order to obtain the dot product between two vectors A and B which are coplanar, then it is represented as A dot B is equal to magnitude of A into magnitude of B into cos theta AB. This is the expression for dot product between two vectors A and B. Observe here, in scalar product we don't have any direction component. Since it is a scalar product, we doesn't have any direction component, unit vector component here. We have only the magnitude. Okay, when the angle between these two vectors becomes 90 degree, what happens to the dot product? When theta AB becomes 90 degree, what happens to the dot product? Dot product becomes 0 because those two are perpendicular to each other. Angle between these two vectors becomes 0 means these two vectors are orthogonal, they are perpendicular to each other. Dot product between two vectors which are perpendicular to each other is equivalent to 0. So this is the thing you need to remember. So this vector multiplication is the most used mathematical operation on vectors for our electromagnetic wave theory applications. The first one is dot product. So this is the expression for dot product, that is a dot product between any two coplanar vectors is equal to magnitude of those two vectors into cos of angle between those two vectors. When angle between those two vectors becomes 90 degree, then the dot product is equivalent to 0. We have seen the dot product equation with respect to the given coplanar vectors A and B. This is the equation which we have seen just now. Now coming to the properties of dot product, look at this first property. A dot product is always less than or equal to the product of magnitude of two vectors. See, so what is the maximum angle by which cos theta can have? This cos theta value, the maximum value will be equal to 1. So we cannot expect the cos theta value greater than 1, right? Then multiplication of these two products cannot go beyond this, right? Hence dot product is always less than or equal to the product of magnitude of two vectors, right? See, this, since this value cannot go beyond 1, the product of these two must be less than or equal to the product of the magnitudes. The product of these two vectors are always less than or equal to the magnitude of these two vectors. When A dot B will be equal to product of magnitude of A and B, when cos theta is equal to 1. When theta becomes when cos theta becomes 1, when theta is equal to 0, cos 0 is 1. In that case only we will get the maximum value here. In rest of the cases, cos theta value is always less than 1, then the product of the dot product of these two coplanar vectors always less than product of the magnitude of A and B. Okay, so this is what the property 1 says. Coming to the property 2, dot product can be positive or negative depending on cos theta value. Based on the angle, the value of this cos theta decides. Based on the value of cos theta, the direction or the positive and negative sign of the dot product depends. That is what the second property says. Coming to the third property, see, look at this. According to dot product equation, A dot B is equal to AB cos theta. In order to obtain the directional vector, that is unit vector for this, the above equation can be solved in this fashion. You just cross multiply this B, magnitude B, so we will get this form. This is equivalent to the unit vector A cap B, where unit vector A cap B shows the direction of the vector B. See, the component of the vector in the given direction, where A cap B shows the component of the vector in the given direction. Then coming to the fourth property, dot product is commutative. Commutative means A dot B is equal to B dot A. Okay, then dot product is distributive. This dot product obeys both commutative property as well as distributive property. A dot B plus C can be written as A dot B plus A dot C. Then one more important property is scaling property. Scaling property is also called as multiplication by scalar. Look at this, we have dot product between A and B, which is multiplied by a scalar quantity R, where small r is the scalar quantity here. If we perform scalar multiplication for a dot product of two vectors, which can be written in this form. Okay, so this is what scaling property says. Then coming to the next property, how to find the magnitude of a vector by using dot product. By using dot product, magnitude can be obtained in this fashion. See, if we perform dot product between the same vectors A and A, so which can be written in this fashion, since we are finding the dot product between the same vector, theta is always 0, the angle between the same vector is 0, hence cos 0 is 1, A into A becomes A square. So what is the agenda? Obtaining A, that is magnitude of vector. So if we solve this equation, A is equal to square root of dot product between these two vectors, same vectors. Okay, these are the different properties of dot product. Now one more important thing you need to remember. See, if we perform scalar multiplication here, multiplication by scalar, based on the sign of this vector, sign of this scalar, the resultant is going to vary. Suppose if R is positive, the scalar R is positive, then the dot product is positive. Then dot product is positive. If R is negative, dot product is negative. Based on the scalar which we are multiplying to the dot product, the sign of the dot product depends. Keep that in your mind. So which is very helpful while solving problems. Then coming to the next topic, vector or cross product. So what we are performing here, again multiplication only. In multiplication, vector multiplication, we have two types. One is dot product, another one is cross product. Now dot product and its properties is over. Now we have moved on to the cross product, or we can say vector product between two coplanar vectors A and B, which can be defined as cross product between vector A and B is equal to magnitude of A into magnitude of B into sine theta into A cap n. What is this A cap n represents here? Since it is a vector product, we are performing multiplication of two vectors. The direction is very important. The previous one was scalar product, where direction is immaterial. Now the direction is very important, where A cap n is the unit vector which specifies the direction of this cross product A and B, where A cap n is the perpendicular to the plane of the plane containing A and B. These are the two vectors which are in same plane, hence we call it as coplanar vectors A and B. The direction of these two, the cross product of these two vectors is perpendicular to the plane containing A and B. This is shown in this particular diagram. Okay, coming to the properties of this cross product, the first property says that cross product is not commutative. Therefore, A cross B cannot be equal to B cross A in this case. Okay, cross product between two vectors is distributive. See, we can easily say that it is distributive. Okay, by looking at this expression, cross product between any two vectors are distributive. Then coming to the scaling, which is similar to the previous case, dot product. See, multiplication by a scalar to a cross product can be represented either of these two forms. These are the three properties for cross product you need to remember. Okay, dot product between, and look at this, a dot product between any two vectors maximum equal to 1, and cross product is between any two vectors at the maximum case will be equal to 0. That means A cap x dot A cap x is equal to 1. Similarly, A cap x into A cap x is equal to 0. This is not into, this is cross product between two unit vectors along the same direction is 0. Dot product between two unit vectors along the same direction is 1. Okay, so you need to remember this. Dot product between two similar unit vectors is equal to 1. Cross product between two similar unit vectors is equal to 0. That is very important property you need to remember for the further discussion. Till now we have seen the vector multiplication operation with respect to dot product as well as cross product. Now this vector multiplication to be seen with respect to the coordinate system. So let us choose rectangular coordinate system and represent vector multiplication in 3 dimensions. Okay, so vector representation in 3D. Vector representation in 3 dimensions. So in that case, let us choose first dot product. So here in this case, let us represent vector A in terms of Cartesian coordinate system, that is Ax into A cap x plus Bx into plus Ay into A cap y plus Az into A cap z, and vector B is represented as Bx into A cap x plus By into A cap y plus Bz into A cap z. Now what is the agenda? We need to perform dot product between coplanar vectors A and B. We need to find A dot B. So if we perform A dot B for the above two equation, what are the possibilities we are going to get? We are going to get 9 possibilities, that is A cap x in terms of A cap x, dot product of these two vectors A cap x in terms of A cap x, A cap x in terms of A cap y, A cap x in terms of A cap z. Dot product between these 3 components, A cap x dot product with x, y, z component, then dot product between y component and x component, y component and y component, y component and z component. Similarly, dot product between z component and x component, z component and y component, z component and z component. See, We know that x, y, z coordinates are perpendicular to each other. Therefore, the angle between x and y is 90 degree, angle between x and z is 90 degree, angle between x and x is 0 degree. Got it? Now, based on that, we have the dot product equation, that is magnitude of A into magnitude of B into cos theta. Theta is the angle between these two vectors. Now, A cap x is the unit vector of first one. Again, A cap x is the unit vector of second vector B. Now, the angle between these two is 0. Therefore, since these two are unit vectors, this value is equal to 1. Then what about this value? Since x and y are perpendicular to each other, the angle between these two is 90 degree, cos 90 is 0. Therefore, this quantity is 0. Similarly, if we perform the same operation throughout these 9 possibilities, A cap y into A cap y is 1, A cap z into A cap z is 1. Then rest of the values are 0. Therefore, which results in A dot B is equal to, look at this, AX A cap x into Bx A cap x plus Ax A cap x dot By A cap y plus Ax A cap x dot Bz A cap z, okay, plus Ay A cap y dot Bx A cap x plus Ay A cap y dot By A cap y plus Ay A cap y dot Bz A cap z plus Az A cap z dot Bx A cap x plus Az A cap z dot By A cap y plus Az A cap z dot Bz A cap z. By looking at this expression, the cross product, dot product between Ax and Ax is 1, dot product between x and y is 0. Then all these terms becomes 0, because these quantities are perpendicular to each other, hence these terms becomes 0. We left with only 3 terms. Dot product between A and B is equal to Ax into Bx into A cap x dot A cap x plus Ay By A cap y dot A cap y plus Az Bz into A cap z dot A cap z. We know that A cap x dot A cap x is equal to 1. We have seen already. Then A dot B is equal to Ax Bx plus Ay By plus Az Bz. This is the dot product between these two coplanar vectors. We are just multiplying their magnitudes in each direction and summing all the components. We are going to get dot product between A and B coplanar vectors. Then move on to the vector product. Now second one is vector or cross product representation in terms of 3D. See, before going to this, let us have the three-dimensional view of this. This is Z, this is Y, and this is X. If the direction is clockwise, then we have to take negative direction. Okay. If the direction is anti-clockwise, we have to take positive direction, positive sign. So if the direction is clockwise, then we need to have the negative sign. If the direction is anti-clockwise, then we need to have positive sign while performing cross product between any two vectors, any two unit vectors. Okay. Now in the same fashion, we need to perform cross product between two coplanar vectors A and B. Okay. Then what we are going to get, A cross B is equal to magnitude of A into magnitude of B into sine theta into A cap n, right? A cap n. What is A cap n? It is a unit vector which gives the direction component of this cross product between two vectors, right? Where A and B are the magnitude and sine theta is the angle between these two. Now here also we are going to get 9 possible cases, that is A cap x cross A cap x, A cap x cross A cap y, A cap x cross A cap z, and A cap y cross A cap x, A cap y cross A cap y, A cap y cross A cap z. Similarly, A cap z cross A cap x, A cap z cross A cap y, A cap z cross A cap z. Here in cross product, this quantity becomes 0, this quantity becomes 0, and this quantity becomes 0. Why? We have sine theta. The angle between x and x is 0. Sine 0 is 0. Hence, the cross product between the same axis vectors becomes 0. Got it? That's why these three components are 0. Since we have sine component in the given cross product equation, sine 0 is 0 always. Then what about these remaining 6 components? So we need to consider the axis in clockwise and anti-clockwise direction in order to obtain these things. Got it? Now let us write the vector A in Cartesian coordinate system. This can be represented as Ax into A cap x plus Ay into A cap y plus Az into A cap z. Then vector B is represented as Bx into A cap x plus By into A cap y plus Bz into A cap z. Got it? Now what happens to this? Let us write all these things here. Okay. A cap x cross A cap y is equal to what? See, x comes first, y comes next. Xy, it is in anti-clockwise direction. Hence, we should have the positive axis. Then A cap x cross A cap y is equal to A cap z. We need to take the next coordinate x, y and z, which is in anti-clockwise direction. Hence, positive sign comes. X, y, what is the next one? It is z. So this one gets over. Then A cap x cross A cap z. X and z. X comes first, z next. So it is in clockwise direction. Hence, so what is the sign of this? Minus A cap y, which is the next one. X, z and y. Y is the next one, which comes in clockwise direction. Hence, negative sign comes here. Similarly, the next one, A cap y cross a cap x is equal to C. Y, then x, it is in clockwise direction, then comes z, hence minus a cap z. Next one, a cap y cross a cap z, y z, then comes x, y z x, which is in anti-clockwise direction, hence it is positive. Okay, similarly, let me write here itself, a cap z cross a cap x is equal to z x, then a cap y, then a cap z cross a cap y, a cap z, z comes first, y next, and x comes later, so which is in clockwise direction, hence negative sign should come. This is minus a cap x. By using these results, we need to perform the cross product between these two. A cross b is equal to, write it. So which are the components we are going to get? Only 6 components we need to write. The first one is, let me write here, a cap x, these two components won't come, this into this and this into this. Ax, a cap x, okay, cross by, a cap y, plus ax, a cap x, plus bz, a cap z, okay, plus, then this is over, we need to consider this, ay, a cap I, cross bx, a cap x, plus this doesn't come, ay, a cap y, cross, this is cross not plus, cross bz, a cap z, plus az, a cap z, cross bx, a cap x, plus az, a cap z, cross by, a cap y. Okay, now if I try to solve this, b is equal to ax into by, ax into by, a cap x cross a cap y. See, a cap x cross a cap y is equal to a cap z, plus ax into bz, a cap x cross a cap z. What is a cap x cross a cap z? Minus a cap y. So minus sign comes here. Similarly, what is the next term? Plus ay bx, a cap y cross a cap x, a cap y cross a cap x is equal to minus a cap z, a cap z comes here, then minus sign will retain here, then ay plus ay into bz, a cap y cross a cap z, a cap y cross a cap z is equal to a cap x, then plus, what is the next term? Ay, so we have done with this one, this one, this one and this one, so we have to go with az bx, a cap z cross a cap x, a cap z cross a cap x is equal to a cap y, plus az by, az into by, a cap z cross a cap y, a cap z cross a cap y is equal to minus a cap x comes here, then minus sign goes here. Now regroup the terms. A cross B is equal to, regroup the like terms. See, AY into BY minus AZ into BY to A cap X. Okay, then plus Y terms. Y terms are AZ into BX minus AX into BZ A cap Y. Then Z terms are AX BY plus, okay, Z term, another Z term minus AY BX into A cap Z. Okay, now just replace these two terms. So if I interchange these two terms, this becomes AX into BZ, and this becomes minus here AX into BZ, and this becomes what? AY component, another AY component where it is AZ into BX, AZ into BX. So we just interchange these two terms and we have come with negative sign here. Now this component can be represented as determinant between all the components, that is A cross B is equal to determinant of A cap X, A cap Y, A cap Z, AX, AY, AZ, BX, BY and BZ. So this is the resultant. Let me check here. So in order to obtain first term A cap X, so we need to delete these two, AY into BZ minus AZ into BY minus A cap Y into AX BZ, see, minus A cap Y into AX BZ minus AZ BX. Got it? Then plus A cap Z into AX BY minus AY BX. Hence, so this cross product between any coplanar vectors A and B is represented by this determinant. This is very, very important for our next discussions. Got it? Let us go with our next topic, transformation from rectangular to cylindrical coordinates. Why the transformation is required? We know that our rectangular coordinate system representation is easier compared to other two orthogonal coordinate systems such as cylindrical and spherical. Hence, we need to interconvert from rectangular to cylindrical, and cylindrical to rectangular is very much essential in our electromagnetic wave theory discussions. So that's why we need to know how to convert rectangular to cylindrical coordinate and vice versa. Now let us choose a vector A in rectangular coordinate system, that is AX into A cap X plus AY into A cap Y plus AZ into A cap Z. And let us choose the same vector in cylindrical coordinate system. Those values are A rho into A cap rho plus A phi into A cap phi plus AZ into A cap Z. So this is the vector A which we have considered, which is represented in both the coordinate system as follows. So in Cartesian coordinate system, it is represented using x, y, z parameters. In cylindrical coordinate system, this vector A is represented by rho, phi and z. Now this is given. The objective is to convert from rectangular to cylindrical coordinate system. Now A is given in terms of rectangular coordinate system, we need to calculate this one. Therefore, the objective is to calculate A rho, A phi and Az. These are the things we need to calculate. Okay. In order to do so, we need to have this projection. That is, this A rho unit vector to be represented in terms of x, y and z coordinate. Similarly, A cap phi component need to be represented in terms of x, y and z components. As usual, we know that Az component is same in both rectangular and cylindrical coordinate system. No need to project that one. Okay. Now let us move on to the first thing. How to calculate the projection A cap rho in terms of A cap x. Let me write here. A cap rho in terms of A cap x, that is the dot product we are finding. A cap rho dot A cap x. See, in order to project A cap rho on x axis, what you are going to get, see here, this is phi, this angle is phi, this is the adjacent side to this phi, then this becomes cos phi. And what about this? This becomes sin phi. So x component is cos phi, y component is sin phi. Hence, so A cap rho projection on x axis is equal to cos phi. Cos phi. Similarly, rho component along y axis is sin phi. A cap rho dot A cap z is equal to what? Is equal to 0, because rho and z are perpendicular to each other. In cylindrical coordinate system, rho, phi and z are perpendicular to each other. Therefore, dot product between any two perpendicular component is always equal to 0. This is the result. Now, we need to represent A cap phi in the similar fashion with respect to x, with respect to y, with respect to z. This we already knew. The perpendicular quantities dot product is 0. We need to calculate these two things. For this one, we need to refer into this projection. See, A cap phi and A cap rho are perpendicular to each other. That's why I have written in this fashion. These two are perpendicular. The angle between A cap phi and A cap rho and A cap phi is 90 degree. Now, this vector need to be projected with respect to x, y and z direction, z axis. So, A cap phi is projected with respect to A cap x, hence the angle between these two is 90 plus phi. Therefore, this becomes cos of 90 plus phi. What is the result? Cos of 90 plus phi is equal to minus sin phi. This is the result. What about this one? See, the angle between y and A phi is phi, because this is 90 degree. This angle is again equivalent to phi only. Then this becomes cos phi. Cos phi. Then what about A phi and Az? With respect to this result, these two are perpendicular to each other, hence this quantity is 0. Now write the equation here. In order to obtain A rho, we need to have the dot product between A and A cap rho. To find A phi, we need to have the dot product between vector A and A cap phi. To calculate Az, we need to have the dot product between vector A and A cap z. Let us go one by one. The first one, A rho is equal to vector A into A cap rho. This can be represented as, what is ax into a cap x plus ay into a cap y plus az into a cap z dot a cap rho. So the resultant is, see, ax dot a cap rho is ax dot a cap rho is cos phi, that is ax into cos phi plus ay into a rho is sin phi, ay sin phi, a rho and az is 0, just leave it. Then coming to a phi is equal to a into a cap phi, a dot a cap phi, which is again ax a cap x plus ay a cap y plus az a cap z dot a cap phi. So a phi is equal to, see, ax dot a phi is equal to minus sin phi, therefore a minus ax into sin phi plus ay into a phi, ay dot a phi is equal to cos phi, therefore ay cos phi. What about third quantity? Az and a phi 0, because perpendicular to each other. This is a phi component. Then coming to az is equal to a dot a cap z, which is given by ax a cap x plus ay a cap y plus az a cap z is in dot a cap z. Look at this here, ax dot a cap z, these two are perpendicular to each other, answer is 0. Ay dot a cap z, perpendicular to each other, answer is 0. Az dot az, we left with only az into a cap z dot a cap z, therefore az component is only, this is 1, unit vector is 1, az is equal to az only. So this is how we need to convert this one. Therefore in cylindrical coordinate system, vector a is represented as a rho. What is that a rho? A rho is ax cos phi plus ay sin phi into a cap rho plus a phi. What is the value of a phi? A phi is equal to ay cos phi minus ax sin phi into a cap phi plus az is again equal to az into a cap z. This is the conversion from rectangular to cylindrical coordinate system. This is the resultant equation. Okay, similarly we need to do for cylindrical to rectangular form. In the similar fashion, we need to convert from cylindrical to rectangular coordinate system. Now in this present case, the given quantities are in cylindrical format. So given vector is in cylindrical coordinate system, we need to calculate the equation for vector A in terms of rectangular coordinate system. Now the unknown quantities are ax, ay and az. These components we need to calculate. How to calculate? To calculate ax, which is a vector a dot a cap x, to calculate ay vector a in terms of cylindrical coordinate system into dot a cap y, az is equal to vector a in terms of cylindrical coordinate system dot a cap z. if we perform these three actions with respect to the same results, we are going to get ax, ay and az components in terms of cylindrical coordinate system. So let us go one by one. Ax is equal to vector a dot a cap x. Now a is in terms of cylindrical coordinate system, a rho into a cap rho plus a phi into a cap phi plus az into a cap z dot a cap x. Now ax is equal to ax dot a cap rho. See, ax dot a cap rho is cos phi. Therefore, a rho into cos phi plus x and phi. Second one, a cap x dot a cap phi. A cap x dot a cap phi is minus sin phi. Therefore, a phi into minus sin phi. Sin phi will be written here. Then this plus sign becomes minus sign. X and z are perpendicular to each other. Hence, it is 0. So, this is the ax component. Then ay is equal to vector a dot a cap y. Again, a rho a cap rho plus a phi a cap phi plus az a cap z dot a cap y. So do the cross dot product between these two. This is equals, okay. Then a cap rho dot a cap y is sin phi, a rho into sin phi, okay, plus a phi and ay. A phi dot ay is equal to cos phi. Therefore, a phi into cos phi. Y and z perpendicular 0. So this is the ay component. Similarly, az component is equal to az component. There is no change here. You can refer to the previous thing. Now, if I rewrite the equation for a in terms of ax, so that is a rho cos phi minus a phi sin phi a cap x plus ay. What is ay? Ay is a rho sin phi plus a phi cos phi a cap y plus az into a cap z. This is the conversion from cylindrical to rectangular coordinate system. Okay, similarly in the same fashion, so here what we did, so we have projected rho, phi and z on xyz axis, and we have projected these three components with respect to the given coordinates x, y and z. The similar fashion we need to convert transformation from spherical to rectangular and rectangular to spherical coordinate system. Okay, so no need to write all these diagrams again. You can easily substitute for that conversion. Okay, see, look at these two tables. So we have summarized the results of the interconversion between cylindrical to rectangular coordinate system and vice versa, spherical to rectangular coordinate system and vice versa. By using this table, you can easily do the conversion from one coordinate system to another coordinate system. You need to remember this. For this one, you need to follow the same set of procedures which we have followed for cylindrical to rectangular coordinate system. But make sure that you have projected the parameters r, theta, phi with respect to x and x, y, z properly. So once you know the projection properly, you can easily obtain this interconversion. Then writing a r component, a theta and a phi component with respect to x, y, z, Similarly, AX, AY and AZ component with respect to r theta phi, you need to follow the same set of dot product equations. So there is no change with respect to dot product here. Understood? So these are the things which we need to know before going deeper into the electromagnetic wave concepts. Okay, these are the vector basics, fundamentals you need to know. So the things which you need to know are vector products, okay, in that dot and scalar products, okay, vector addition, vector subtraction, multiplication, and all the three coordinate systems, and what do you mean by vector, what do you mean by scalar, and interconversion between those coordinate systems. So these are the things you need to know better, so for the further discussions. Okay, thank you.